Hey, so usually I make Unity videos, but in this video I decided to make a JavaScript video just because I found this really cool function to a problem I've been solving, and I ended up getting it in one line, so I thought I'd just share it since I think it could be useful to you guys. So it's a permutations function, so it takes in a list of numbers and it generates a 2D array of every possible permutation of that set of numbers, or it could be a string, anything like that. And yeah, I thought it was pretty cool because I was able to fit it in one line. And when I say that, like you see here, there's no blocks, there's no brackets, there's no code that I just deleted all the formatting and tried to squeeze it in there. It would generally format into one line. And so yeah, you can see it's pretty clean for what it is. And yeah, so I'll just kind of describe it, and I'll describe it similar to the factorial function because I think it's easy to understand that function, so it'll be easier to kind of grasp how the permutations function works. And so if you're not familiar with the factorial function, it's just a way of getting the number of permutations for a given set of numbers. So in this case, there's 3 numbers here, and it generates 6 different permutations, and that's all a factorial does. So you know how, and if you if you don't even know what factorial is, like 5 factorial is going to be equal to 5 times 4 times 3 times 2 times 1, and this will actually give you the number of ways that you can arrange this list in a unique order. And so to do this, you've probably seen the recursive trick where basically you just you call the function again with n minus 1, and you multiply by n. So we have this initial value, like say 5, and then when we call it, we check first our n condition, and then if 5 is greater than 1, then we just return 5 times the factorial of 4, and then that'll be 4 times 3, 3 times 2, 2 times 1, and then that return chain will kind of work its way back up and then produce the final output. And the important thing to note about this function, so if you're not familiar with a ternary, that's just kind of similar to writing an if statement in one line, and the only difference is it evaluates one of 2 expressions, whereas an if statement would evaluate one of 2 blocks of code. And I guess the key takeaway is that you're always checking for the end condition of your recursive function. So in this case, we're checking if n's greater than 1, because as soon as n gets to 1, we just want to return 1, else we'll actually hit 0, and then our function will always be 0. But yeah, that's the important thing, is recognizing where your end condition is. And so you can see it's actually pretty much the exact same setup here. We just have a little bit of more code in between. And so the way I decided to set up this equation, or this function, is with 2 parameters here. And so the first one is your list, and that'll be the list you want to work on. So say we'll just stick with 1, 2, 3 because that's easy. And that's, I want every permutation of 1, 2, 3, every unique order. And so then P here, this is the current permutation. And so because this is a recursive function, this will be initialized at an empty array. And so you don't have to pass this in. Like if I wanted to call this function down here, I wouldn't pass it in with array. I just pass in 1, 2, 3, and I leave this one, because in JavaScript you can leave parameters empty, and then it'll default to an empty array, which is what we want, because initially there is no permutation we're working on. It's empty. And so the way the function works is that it'll take values from the list, and it'll move them into a permutation array which starts empty, and then it'll fill them. So it'll take 3, move it over here, and then so on, just kind of working its way until it creates a full permutation list. And because it's doing this recursively, it's doing this in every possible order, and then it'll return back a big 2D array of all the permutations lists. So like I said, so our end condition is checking if the length of the list is greater than 0, because as soon as that list length hits 0, that means we have no more numbers to pass to our permutation array. So say we did something like this. Now we have no more numbers to add to our permutations array, so we just want to return that array, which is, as you can see over there, that's our end condition. And so then obviously all the times that we're not doing that, we're executing this fat line right here. And so what this is doing is this is calling l.reduce. And so what I'm kind of doing here is similar to the factorial. I am actually, the reduce is a little misleading, but I am combining a bunch of arrays that would be produced from the permutations of a list that has one element removed in it. And I'm passing in a permutations list with one extra element. So to go through, so I'm calling this reduce with an array as my accumulator and just n, which is just the number. It could be anything n. And then if you're not familiar with reduce, yeah, basically it's one of those JavaScript functions that iterates over an array, and array is this is the accumulator. So this is the value that will continuously be passed for every iteration. And like I said, you can add to it. So you could, push elements to an array, or you can add data values to a number, or, add text to a string. And then n, the second parameter of a reduce function, is always the current value that you're iterating over. So in this case, because I'm calling it on a list, I'd be iterating over 1, then 2, then 3. So what I'm returning in this function, so in a arrow function, if you have one line, this is just the return statement. And the return statement in a reduce function is always becomes the new accumulator value, which in this case is array. So I'm doing this .concat here because concat actually returns the entire array, the concatenation of array and whatever this array is. And that's important because if I didn't do .concat, I couldn't do this in one line. And you'll see like I do .concat here because it wouldn't work if I did push n, because this returns n and not the array of p and n. That's an important part of making this whole one-liner thing work. So I'm concatenating to array on another array, and this array is the permutations. Where does it end? Yeah, it's the permutations function called for. I pass in L and P, but notice that this is the key part, is where I modify L and P, because notice in our factorial, when we call it factorial again, we call it but with n minus 1. So we kind of do a similar thing here. We pass in L.filter, which just creates another array similar to L, but it tests for every value in the array, it iterates over every one, and if this function returns true, it'll keep that value in the array. If it turns false, it removes it. So I'm filtering, I'm sorting over L array again, but I'm checking if my sorted value is not equal to the current array I'm iterating over. So what that's doing is that's always going to remove, so whatever index we're on for this iteration, it'll remove this value n from the array, the list array, when it passes it in. So for every branch of this iteration, it'll remove first 3 and then call the function on just 1 and 2. Then it'll remove 1 and call it on just 2 and 3. And lastly, obviously, it'll remove 2. And so obviously, this is crucial to making the list array get smaller, because again, the idea is that we're moving elements from L to P and calling that on a new iteration. And so then for our P value, remember, it starts as an empty array, and the whole point of this P value is that it's the working permutation list we're on. And this is going to be P, it's going to be just P, but we're going to concatenate on N, because remember, we're moving N here from the L array to the P array. And because this reduce function is calling, is iterating over the whole array, it will always create a new instance of this function when it removes every array in different orders. So first it'll remove the 3, and then it'll be working with just 1, 2. And then because it'll call over 1 and 2 again, this entire process will start over, and then it'll remove 1 first. But then, in the next iteration, it'll remove 2 first, and then you'll have 3, 2, 1. And then you'll have 1, 2, 3, and so on until you finish that whole cycle. And then, like I said, our end condition is just P, because remember, we're concatenating whatever this value is. So we actually have to return an array of the P array, because we're concatenating on, if you think about it, it's like, here's your big array of, say, 1, 2, 3, 3, 2, 1. And then for the last step, you want to concatenate an array of, let's say, like our last one is 1, 2, 3. Because if you think about it, all concatenate really does is it just takes the final array out of the picture and then it just moves that into this array. So it'll, that was definitely an oversimplification, but you get the idea. And yeah, that's pretty much all the nuts and bolts to this function. I think it's really useful because you, like I said, like especially with the cool trick of the initial value of p being empty, so that you don't have to always pass an empty array, and it's kind of doing it behind the scenes. I think that this is just a really cool one-liner, and unfortunately, because it's recursive, I don't think this function can be anonymous. So this couldn't be like an arrow function, I don't think. But it's definitely something that if you need this in your code, say, and doing anything with statistics, this is super useful. And I can't speak to its efficiency because I'm definitely using all these higher order functions, but I can say that it looks pretty clean, and I think it's some of the most satisfying code I've ever written. And if you did see this bonus up here, you're going to be a little disappointed, but the bonus I added is to make it a little bit more handy, but with 2 lines. You can actually initialize L. You can have L as either a number or an array. And if it's an array that you want to iterate over, like say you want to create a permutations of a bunch of strings, then yeah, you'd want to pass in an array. But if you want to just create all the permutations of the numbers 1 through 5, say, then you'd pass in just a number to L to make it a lot more simple. And so this line just checks if L is a number, and if it is, it'll set L to this nice little one-liner that'll create an array of length L, and it'll spread it into an array. This is just a little trick because you can't actually call higher order functions off of an array initializer, which is kind of annoying. Actually, that should be new array, I think. Whoops. And this just spreads an array of empty values into an array of size L. And then it'll map those, and I don't care about the value because it's empty, but I care about the index because we're just going to map it to its index. So it'll just be 0, 1, 2, 3, 4, 5, whatever L's length is, and that'll just be set equal to L right off the bat. And then this function will run like normal, and then this line will just be skipped for every subsequent iteration of the permutations function. So yeah, thanks for watching this video. If you made it this far. Pretty cool function. You should definitely add it to your code, and subscribe to my YouTube page. See you guys.